So we now know how to do balanced chemical reactions and ratios of moles of one thing to moles of another thing. We can say, hey, if we've got this reaction that says we need 4 moles of this to 2 moles of this, we can do those ratios and figure out how much reactant we need to make a certain amount of product, how much product are we going to make if we have a certain amount of reactant, and things like that. However, the units are all in moles. And when I go into a lab, I can't walk around and find something that's the mole balance. I'm not going to put something on a balance and it's going to tell me how many moles are in there, because that balance doesn't exist. You can't buy a balance that can just tell you moles without giving it other information. So what can we measure in the lab? Well, we mainly measure 2 different things in the lab, right? We measure mass and we measure volume, right? So how are we going to take those things that we measure in the lab and make them into something that we can use in these balanced reactions which require moles? Well, the first question I think of is, well, can we just use grams in these balanced reactions? And the answer is no. Imagine I said, hey, I've got 4 kilograms of wheels and 8 kilograms of frames. How many bikes can I make? You would have no idea, because you're like, well, I don't know, how many is that? And that's what we need to know in a chemical reaction too. We need to know how many is that. Just because we know it's mass, it doesn't actually tell us how many it is. So what do we want to do? We want to convert it to a unit that's how many. And what's the unit of how many in chemistry? It's moles. So if we have grams, we're going to convert those over to moles. Now, we're not going to do this too much in this class, but it turns out if you have milliliters, you're also going to work on converting those to moles if you've got balanced chemical reactions. But we're going to focus on this first one over here, grams to moles. How do we get from grams to moles? Well, we need something that has units of grams and units of moles. And what is that? That's molar mass. And you remember we get that from the periodic table. So we're going to do this process where we're going to measure things in the lab in grams. Oh, I've got 7 grams of this. How much product am I going to make? And so we're going to convert those grams to moles. And then we can use the balanced reaction to say, oh, I've got 4 moles of this, so I can make 8 moles of that. But then at the end, what are we going to do? Well, we're going to see, did we make the product we thought we would? How are we going to measure that? We're going to measure that in grams. So we're actually going to have to convert our answer back into grams. And so the whole process, people sometimes talk about like this, grams to moles to moles to grams. And we'll highlight that a little bit more. If it doesn't make sense right now, hopefully it'll make sense by the end of this video. So we're just going to do a couple examples. That's always the easiest way to figure out how this stuff works, is to actually make it work. So I've got this balanced reaction here that says nitrogen and hydrogen react to make ammonia. But you see we need 3 hydrogen molecules in order to react with 1 nitrogen molecule. And if we do that, we create 2 ammonia molecules. So we're going to answer 2 different questions. The first question is, how many grams of ammonia can we produce with 14 grams of nitrogen? Now, anytime we've got multi-step unit conversions, it's always nice to have a plan. So let's think about a plan first. We're starting with 14 grams of nitrogen. Now, in order to use a balanced reaction, what do we need? We need moles. And so I want to convert this into moles. Moles of what? Well, it turns out the only thing you can do is grams of something to moles of the same thing. So I can only go grams of nitrogen to moles of nitrogen. It's not possible to go straight from grams of nitrogen to moles of hydrogen. That's not one conversion. That is 2 different conversions. So once I've got moles of nitrogen, what can I do? Well, that's where I want to find my hydrogen. And it turns out how we find that is using the balanced chemical reaction. And what does the balanced chemical reaction tell us? It tells us the moles of one thing compared to the moles of another thing. So I go moles of nitrogen to moles of hydrogen. Now, if I really want to know, how do I check whether I produced what I wanted to produce? I've got to do one more step and convert those moles of hydrogen into grams of hydrogen. And there we've got that grams to moles to grams that I was talking about. Another way of saying it is the grams of what we start with to the moles of what we start with to the moles that we end with to the grams of what we end with. And our plan looks something like that. So now that we've got the plan, remember when you have a unit plan, each one of these arrows is a conversion. So how many conversions am I going to have to do? I'm going to have 3 conversions. So I can just start writing this out. I got 14 grams of nitrogen, and I'm going to need 3 different conversions. 2 and 3. My first conversion here is grams of nitrogen to moles of nitrogen. Where does the grams of nitrogen have to go? It has to go on the bottom, right? Otherwise it won't cancel out. You can't have 2 grams of nitrogen on top and have it all work out. Now what goes on the top here? That's where our plan comes in handy. Our plan says that we're converting those grams into moles of nitrogen, and so we put that there. Step 2. We now have moles of nitrogen, and we want to convert that into moles of hydrogen. So where does the moles of nitrogen go? It's got to go on the bottom. And then what about my hydrogen? I'm trying to convert into that, so that's going to go on top and look something like that. My moles of nitrogen cancel out as I want them to. I've now got moles of hydrogen. And then step 3 is this one here. Where does my moles of hydrogen go? Goes on the bottom because it's got to cancel out. We don't want it anymore. And then what am I converting that into? Third step of my plan tells me that I'm converting that into grams of hydrogen. Everything cancels out. I ended up with grams of hydrogen, which is what I was looking for in my problem, and so I'm good. I can go ahead and stick in those numbers now. So remember, we have to consider each one of these conversions individually to try to get the numbers. Our first one, we've got moles of nitrogen and grams of nitrogen. What quantity do we know that relates grams and moles of something? Hopefully you come up with molar mass. Molar mass relates the grams and the moles. Grams per mole. How do we figure that out? Well, we look up the molar mass, the atomic mass of nitrogen, which is 14.01 grams per mole. But we've got 2 nitrogens, and so we're going to multiply that by 2 to get 28.02 grams per mole. Now, where does that 28 go? Remember, you don't memorize it goes on the top or on the bottom. You memorize that it stays attached to its unit. What unit is attached to? It's attached to grams. Grams is on the bottom, and so I'm going to put it down there, and that per mole means per 1 mole. All right, in my next step, I've got moles of hydrogen, moles of nitrogen. I've got moles of one thing, moles of another thing. What is the place that I go to look for those numbers? Straight up to my balanced chemical reaction. And again, I just copy paste from there. I don't try to fix it. I don't try to make it better. I don't try to take into account any other numbers. It's just a straight copy paste. I look in front of hydrogen, it's got a 3. I look in front of nitrogen, it's got a 1. And so that's what I put in there. In my last one, I've got grams of hydrogen and moles of hydrogen. What relates grams and moles? You're right, molar mass. But not the same molar mass I calculated before, because I calculated it for nitrogen. Now I need to calculate it for hydrogen. So we look up hydrogen on the periodic table, but there's 2 of them, and we get 2.02 grams per mole. Where does that 2.02 go? Again, don't memorize top or bottom. Memorize it's attached to its unit. The 2.02 is attached to grams, and so it stays attached to grams on the top. If we multiply all that out, what do we get? I think I know the numbers, but let me just make sure. We get, oh funny, I didn't write down the answer there. 14 divided by 28 is a half, times 3 is 1.5, times 2 is 3.0 grams of hydrogen. Where did we get those significant figures? We started with 2 significant figures. Our molar mass there has 4. This 1 is exact, so we don't worry about it. This ratio is exact. We're just counting those atoms and molecules. Our other molar mass has 3, and so we're limited by the 2 sig figs that we started with, and we get 2 sig figs in our answer. So that's how we do a grams to moles to grams problem, what we call stoichiometry, the ratio of elements and atoms. We're going to do a very similar problem we are going to do this next one here. We're going to say how many grams of hydrogen do we need to do it? And what we mean by do it is to react with 14 grams of nitrogen. So we're going to start with our 14 grams of nitrogen. Did I answer the wrong one? Ah, I did. I answered the wrong one. I did the H2 one first. Hopefully that didn't confuse you too much. Alrighty. So let's do the ammonia then. If we want to do grams of ammonia, what do? We're going to put it down here, and it's going to look like this, grams of NH3. My apologies. I really hope I wasn't confusing you too much. We know there's going to be 3 conversions because we're doing grams of nitrogen to moles of nitrogen to moles of ammonia to grams of ammonia, and each arrow is a conversion factor. This first conversion factor should look awfully similar, grams of nitrogen to moles of nitrogen. So I can actually just copy that from what I have up there. My moles of nitrogen to moles of ammonia, moles of nitrogen's got to go on the bottom, so that was 1 on top, 1 on bottom, and those cancel. And then what goes on top is moles of ammonia. And the next one, moles of ammonia, has got to go on the bottom, otherwise it won't cancel. And what goes on top is just the thing we're looking for, which is grams of ammonia. Where do we get the ratio of moles of ammonia to moles of nitrogen? Straight from our balanced chemical reaction. We look at ammonia there, it's got a 2. We look at nitrogen, it's got a 1. We get a 2 there, we get a 1 there. How do we get grams of ammonia versus moles of ammonia? Again, that's molar mass. Anytime you see grams of something and moles of something, it's molar mass. And we add it up, 14.01 grams per mole for the nitrogen, 1.01 grams per mole for the hydrogen, and we've got 3 of them, and so we get 17.04 grams per mole. Where does that 17 go? It stays attached to its unit. It's attached to grams, and so we get something that looks like that. Now, it's very tempting. I'm going to show you a mistake that people make a lot. That 1 down here. Oftentimes people see that 2 here and they want to copy that 2 down into that 1, but don't do that. What is this number over here? This number over here is the grams in a mole. The periodic table only knows how many grams there are in 1 mole. That's all it knows. It doesn't know anything else. It doesn't know how many grams are in 2 moles or 3 moles or 4 moles. It knows how many grams are in 1 mole. So anytime you've got this grams to moles ratio, the number in front of that moles had better be a 1. Don't ever try to copy any of your other coefficients over to there. All right, what do we get? We get 14 divided by 28 is a half, times 2 is 1, times 17 is 17 grams of ammonia. Again, my 2 sig figs come from my starting 2 sig figs in my nitrogen. And that is how we do grams to moles to moles to grams. We set up, we have a plan that we know. It's grams of what we start with, moles of what we start with, moles of what we're ending with, to grams of what we're ending with. We set up those 3 conversion factors. The nice thing about these problems is they're all very similar. So you can also just memorize, if you want to, set up 3 conversion factors. Okay? So make sure you're always doing these grams to grams problems using 3 conversion factors. All right, here is one for you to work on. For the balanced reaction, we saw this one before. We were doing it in moles and moles. Now we're going to do it in grams and grams. Okay? How many grams of CO2 are produced if we start with 16 grams of oxygen? I want you to pause the video, try to work this one out, get the right answer, and see where you went. All right, we're going to start with 16.0 grams of oxygen. We know we need 3 conversion factors to do this guy. So we're going to write out our 3 conversion factors. What's it going to be? It's grams of what we start with, to moles of what we start with, to moles of what we end with, to grams of what we end with. And so it looks something like that. Our first is going to be grams of O2 to moles of O2. Where does the grams of O2 go? It's got to go on the bottom, otherwise it won't cancel. And we get moles of O2 up top. Our second one, moles of O2, where does it have to go? It's got to go on the bottom. Even if we know nothing else, even if we aren't sure what to do next, what goes on top, we know this guy goes on bottom because otherwise it won't cancel out. So what goes on top in my second conversion step? It's to moles of CO2. And then in the next step, what goes on the bottom? It's moles of CO2, otherwise it won't cancel. Right? There's a pattern to all of this, pattern of canceling units. And then what goes on top? Well, we're trying to get to grams of CO2. And so that's what goes on top. Where do we get these numbers from? Moles of moles of O2 and grams of O2. That's molar mass. O2 is 16.00 grams per mole times 2 is 32.00 grams per mole. Be very careful about those zeros. You do want to keep those zeros in there since they were part of your O2. They are part of, they were part of your oxygen. They are part of the significant figures of your O2. And so we get 32.00 grams per mole. If you shorten that to 32.0, you're going to miss out on to 32, you're going to miss out on a sig fig that you can get in this problem. So we get 32.00. How did I know it went down there? Because units stay attached to their numbers. 32 is attached to grams, and he stays attached to grams. The next one, moles of one thing to moles of another thing. Where do we get those numbers from? Straight from our balanced chemical reaction. There is a 2 in front of CO2. There's a 3 in front of an oxygen. And so I just copy those numbers down. I copy the 2 down. I copy the 3 down. Then where do we do in the next one? Grams of CO2 to moles of CO2. Hopefully, again, that comes up in your brain as, oh, molar mass. Let me go to the periodic table. 12.01 grams per mole plus 16.00 times grams per mole times 2. If you work that out, you get 16 and 16 is 32, 42, 44.01 grams per mole. Where did the 44 go? It's attached to its unit, and so it goes up here. Now, sometimes people have trouble with how do you put this kind of math into your calculator. So let me just tell you what I'm about to type into my calculator, and then I'll type it in. I'm going to type in 16.0 divide by 32 times 2 divide by 3 times 44.01. And if you type it in just like that in your calculator without any parentheses, it'll all work. You can certainly do everything on top, 16 times 2 times 44, divide by parentheses 3 times 32. You'll get the same answer. But if I can avoid parentheses in my calculator, I usually do because it makes my life a little bit easier. So let me actually type that into my calculator right here. I'm going to type in 16.0 times, divide by 32 times 2 divide by 3 times 44.01, and I get myself 14.67 grams of CO2. I have 3 sig figs from my 16 up here, and so I get 3 sig figs here, and I get 14.7 grams of CO2 as my answer, which is answer C there. So you can see these problems take time. There's no real great shortcut for them. Certainly you can memorize the pattern, and that helps you do it reproducibly, but it's going to take you several minutes regardless of what you do. Grams to moles to grams is how you do this one. And we're doing what's called stoichiometry, finding how much reactant we need to react with something, how much product we're going to make. Any ratio inside that reaction we can do. Hopefully these videos were helpful. See you later.